Hello all. So in the last session we have discussed about various classification algorithms. We have covered the theoretical aspects of all different classification algorithms, KNN, decision tree, random forest, okay, support vector machines, etc. So from today onwards we will be discussing about the experiments on each of the algorithms that we have covered so far. So today in this session I would like to cover about how do we implement logistic regression. Okay, this is experiment 6 as per your syllabus. So how do we implement a logistic regression algorithm on a given data set, and we have to check for the accuracy on the test data set. Okay, so basically before we actually step into the experiment part, let's quickly recap about what logistic regression algorithm was all about. Okay, so we've seen that logistic regression is a supervised machine learning algorithm which is used majorly for classification problems. And like when you talk about linear regression algorithms, it predicts the probability of a target variable which has continuous values. But when we talk about logistic regression, we use this particular logistic regression to find out the specific class of a target variable. Okay, and apart from that, even if you have continuous values, okay, logistic regression algorithm will adjust that to the outcomes between 0 and 1, for which we use sigmoid curve. Okay, so we have seen the logistic regression algorithm puts some threshold and adjusts all the predicted values in between 0 and 1, so for which we will get a S-shaped curve, right? So we have seen the theoretical aspects of logistic regression in the previous sessions. So now let's see how do we implement logistic regression step by step. Okay, so before we actually go into that, these are various advantages of logistic regression algorithm. It works well when the database is linearly separable, easier to implement compared to any other any other algorithms, provides valuable insights within the given data. Okay, now to begin with, let's start with step 1, which is basic reading the libraries and then loading the data set. So first we import the required libraries and work on the given data set. Okay, now the data set that I have taken here is a Titanic data set used for this particular experiment. Here you can choose your own data set and work on any of the data sets. Okay, so it contains, basically the Titanic data set contains the data of the passengers who have boarded the Titanic ship. Okay, so the data set actually contains various informations about the passengers like age, gender, and other travel details like ticket class, fare, and etc. There are so many other parameters that are included in the data set. So our goal is to predict whether a passenger can survive or not. So there is a column called survived column. So we have to predict whether a passenger can survive or not. 0, 1, 0 not survived, 1 survived, depending upon various parameters of the data that is available. Okay, now let's see how do we load the data set. So before we load the data set, we have to import the libraries. So here for this experiment, we have to import pandas for reading on the data set, and I've import Seaborn for visualization, for graphical visualization of the entire data set or the predictions, and then matplotlib also for visualizations. From sklearn model selections, I've imported train test split. Already I have told you that the entire data set divided into train and test. Okay, train data for training your model, test data for checking the accuracy of the model. Okay, now from sklearn.linear_model, I'm importing this model which is called as logistic regression. As I told you, L should be capital, R should be capital here. Okay, so like linear regression, we also importing logistic regression model, and from sklearn.metrics, I'm importing accuracy score. As this is classification problems, we have seen various performance metrics for classification, right? We've seen confusion matrix and then accuracy, precision, recall, and all that. So as for the given problem statement, we're supposed to find out the accuracy. Hence, I'm importing from the sklearn.metrics, I'm importing accuracy score, and I also want to generate the classification report and also print the confusion matrix. Okay, so if you don't, all these are not optional. Okay, only accuracy score is asked, but if you want to get the accuracy score, you also can view confusion matrix, classification report, and from which you can clearly analyze or visualize the accuracy score calculations. Okay, now once I'm done with importing the libraries, we'll start loading the data set. So I've given a URL. Okay, so from somebody's account in GitHub, I have taken this Titanic CSV file. So using the Titanic dataset as example here in this particular example, so I want to just have a preview of the dataset and print some 5 columns. Okay, so let's see. This is the dataset all about. Okay, so we have passenger ID, we have survived. Okay, this is the output target class. We have P class. Okay, and then we have ticket type, fare, cabin, so many other name of the passengers, the gender of the passenger, age of the passenger, so many other details. Okay, so most of the details may be irrelevant, so I want to pick up only few input features for predicting the survival rate. Okay, so what I do is I try to pre-process the data. Okay, there are various steps again in pre-processing. First is feature selection. I don't want to include all these features which I don't even know the names about. What is this embarked, what is this SIP, I don't want to take the ticket number and all that, because I don't think all these input features will contribute for the prediction. Okay, so I want to select only few features, like class of the ticket that they have taken, because the survival rate may also depend the class, because the higher class ticket they take, more facilities they may have for escaping from any tragedy. Okay, so I have considered P class, the age of the gender of the person, age of the person, etc. Only few parameters for predicting the survival rate, which are of most importance. Okay, and then I also do this processing of categorical encoding, because the sex column, in the sex column we have female and male. Okay, I want to give encoding 0 and 1 instead of using the strings, so I perform categorical encoding there. And then after that, let's handle missing values, because if you have missing values in the data, it affects the accuracy of the model. So we also have to do some pre-processing, wherein you handle the missing data, remove the missing values and replace it with NaN. Okay, so after I do pre-processing, I'll split the entire data set into training and testing. 80% would be given for training and 20% would be given for testing. Now with this training data we use for fitting the model, and test data is actually used for evaluation. Okay, now let's see this. So first I'm selecting only the relevant features that I want. Okay, this is completely optional. You can pick only 4 features, or you can pick all the features. That's all depending upon what you want to take. Okay, so selected features is equal to, I've taken some features, and then I say selected features plus survived. Okay, this is the output column that I want to take. Okay, so the data set should include the selected features along with the survived column, wherein the selected features would be the input, survived would be the output. Okay, now in this particular, when I want to when I look into this particular column called gender or sex, okay, I want to replace that with categorical values. So I say male is equal to 0, female is equal to 1. Represent male with 0 value, female with 1 value. So this is one part of pre-processing. Two parts of pre-processing. First is selecting relevant features, second is encoding categorical data. Okay, now if I want to check with missing values, I just want to drop the rows with the missing values, so I simply use the function from numpy, which is drop now. Okay, so in pandas you have this drop now function, which will drop all the rows with missing values. Okay, now once I am done with that, in X I take my selected features, in Y I take my survival data. This is my input, this is my output. The entire data set consists of input and output, so I want to separate that. So X is equal to data of selected features, Y is equal to data of survival. Now these are the input features, this is the target variable. X has input features, Y is the target variable. Okay, once I am done with that, I'll split the data into X train, X test, which is training data, Y train, Y test, which is test data. Okay, as I told you, 80% of the data would be taken for testing and 20% of the data would be taken for, 80% for training, 20% for testing. Hence test size is equal to 0.2 is what I have declared. Okay, so in step 1, I've simply imported the libraries and loaded the data set. In step 2, I have pre-processed the data set. That is, I've selected only few features that have most importance, and then I have encoded the categorical variable for the column sex, and then I have dropped the rows with the missing values, and then I have selected what are the input columns and what are the output column, and then finally I have divided the data into training and test. Okay, now once I am done with that, let's start building the logistic regression model. Okay, so already we have imported logistic regression function, right? So I am just instantiating this particular thing with the input features. Okay, that is, I want to load the logistic regression model and fit that with respect to X train and Y train. Okay, so I am taking a variable called model, in which I am importing this particular instantiating logistic regression model, and in that I am fitting, for this model I am fitting that with X train and Y train. As discussed, training data is used for training the model, right? I am doing the same in step 3, and once I am done with that, I want to make some predictions. Okay, I know what is Y test, I know what is Y train, what is y test, okay, but I want to compare my y test with y predictions. I want my model to generate y prediction, okay. So the model predict outcomes y prediction for the given data set X test. I know what is y test. Instead of y test, I want to hide them, and for given X test, I want my model to go for y predictions, okay. So these predictions will indicate whether a passenger is likely to survive or not, and that would be compared with y test. X test is the input, y test is the output which we already know, but I want to hide that and go for y predictions, okay. So here I am going for y predictions, that is I have already developed a model and I am using the function predict for X test, okay. So once I am done with that, I want to print first 10 samples. So I say print y prediction 10 and y test 10. Y predictions is the predictions made by the model for X test input. Y test is nothing but the original output of y test for the same X test, okay. I want to print the first 10 values. As you can see, once you print, you will be getting the 5 prediction values, okay. I didn't put the output here, but you can just try and check that out, okay. So once I am done with the testing, I want to go for evaluating. I don't know to see, I am only printing 10 values, but for the entire data set, I want to check what is the percentage of correct predictions, okay. So for which we will use the performance metrics, okay. So you know what accuracy is all about. First of all, we have seen confusion matrix, which is basically the visualization of the performance of the classification model, which will contain true positive, true negative, false positives, okay. So this is the confusion matrix, as we have seen, actual values minus predicted values, true positive, true negative, false positive, false negative. So accuracy is all about true positive plus true negative by all predictions, right. So accuracy, measure the percentage of correctly predicted labels in the test data set, and we will generate the classification report, which includes all the other performance metrics, okay. So here accuracy is equal to accuracy underscore score. We have already imported accuracy underscore model, and for which y test and y prediction. What are the actual values? What are the predicted values? Based on this, I will have my accuracy score calculated. I want to display it as percentage, hence I am printing this. And then along with this, I also want to print other performance metrics, hence I generate the classification report. Same for y test and y prediction. As you can see, the accuracy test on the data is 74.83%, okay. So I got 74% accuracy for all the test data that I have taken, and this is the classification report, which gives you how many precisions, how many recalls, F1 score, support, accuracy, macro average, macro average and weighted average, 74, okay, 74 and 75 about, this is all about the classification report. Once I am done with the predictions, I just want to go for simple visualizations, okay. So here you can use matplotlib and seaborn, okay. I want to print my entire confusion matrix, so I'm using seaborn here, okay. So displays the confusion matrix using a heat map for an intuitive classification errors, and I also want to go for prediction distribution, like a count plot of how many predicted classes are positive or how many are negative. In our case, how many have survived, how many of them are not survived, okay. So simple visualization. We have already imported the function confusion matrix in the libraries in the first step, okay. So for y test and y prediction, I want to display the confusion matrix. These are different, attributes that you can do for displaying the confusion matrix. I want to go for color blue. You can give your annotations, X tick labels, Y tick labels, how do you want to display them and all that. Plot title, confusion matrix, label, prediction and actual. I want to, on the x-axis I want to go for predicted values, on the y-axis I want to go for actual values. And distribution of predictions also, I want to go for count plot, and I want to distribute predicted class and the total count, okay. Let's see the visualization. As you can see, this is the heat map, okay. So survived, not survived, survived, not survived on x-axis and y-axis. On x-axis it is predicted, y-axis it is actual, okay. On x-axis predicted, y-axis actual. I am printing what? X tick labels not survived and survived, Y tick labels survived and not survived, okay. These are the labels, tick labels that I am taking, and the title is confusion matrix. So depending upon the count that we have generated, you will be getting true positive, true negative, false positive, false negatives, okay. So this is your confusion matrix, and I am going for distribution of predictions using seaborn, the count. So total prediction classes are 2, 0 and 1, survived, not survived, and the count of each of them, okay. So this is how the distribution is done, and this is the visualization. Okay, so these are the steps, guys, 6 steps. Let me repeat them once again. Step 1, load the data set. Import all the libraries. See, here you can see accuracy score, classification report, confusion matrix already generated, loaded. Okay. So, step 1, import the libraries and load the data set. Step 2, do some pre-processing, handle the missing data, encode the categorical variables, do some feature selection if required. Okay. And then train the model, fit the model with X-train and Y-train. Once you are done with fitting, you have to go for prediction. Prediction will be done for X test as input, you predict your Y predictions. Okay, so this is all about making predictions. Once we are done with predictions, we'll go for model evaluation. Okay, so using confusion matrix accuracy, I want to evaluate the model. Along with accuracy, I also want to display other performance metrics like precision, recall, F1 score. And then once we are done with that, we'll go for some visualizations. Okay, so this is all about logistic regression model on a sample data set. Thank you.